Hello, hi, this is Nobleman Science Tutors Online. You are welcome to our class for today. Before then, I also want to welcome you to a brand new year. This is 2023. In 2022, we started this channel and we did a lot. This year, we are promising you that we are going to cover more and then we'll introduce some other subjects too. We know that this is an examination year. Some students in West Africa, they will be writing their West African School Certificate examinations. Others will be writing different external examinations. So we'll try as much as possible to complete the curriculum for physics and then do some review questions. Okay, so please, if you are just visiting this channel for the first time, you are welcome to Noble Mind Science Tutors Online, and this is your physics tutorial. Okay, so if you have not subscribed, please click on the subscribe button, click on the notification bell so that whenever we upload a new video, YouTube will notify you, right? Okay, so and if you have any question that you want us to attend to, you can reach us via the WhatsApp number that's showing on your screen, or you click on the link that is under this video. All right, so you can always reach us through those channels. Then you can also place your comment on the comment section, right? So please, I will encourage you, invite your friends to come and enjoy what you are enjoying. Also give us a thumbs up if you like what we are doing, and we've gotten a lot of lecture materials on our channel, so visit any of the topic that is of your interest and then follow through. If you have any question, please just reach us. We'll try as much as possible to respond to your questions. Alright, so guys, for today's lecture we'll be looking at electric field. Remember that we've treated electric field before in our previous video. You can search for that video and also watch it. Okay, so for today's topic we'll be looking at production of continuous charges, production of continuous charge or production of current. Alright, so we look at different ways in which current can be produced from primary cell, example of which is Daniell cell or Leclanché cell. We'll also look at the working of a secondary cell and then take some summary notes. So basically we're looking at production of continuous charge. That's what we're going to be looking at in this particular video. So please guys, get your writing materials ready so that we can go straight to the class for today. So if you are ready, please let us go. So as I said, in our class for today, we'll be looking at production of continuous charge. When we treated electric field in our previous class, we said that electric current is produced by an electric charge that is in motion. Okay, so an electric charge that is in motion is known as electric current. So for you to have a continuous flow of charge in motion, you can only get that either from a primary cell or from a secondary cell. And what does a cell do? A cell converts chemical energy to electrical energy, right? So you have example of your battery cell. Your battery cell is a primary cell actually. So once you join the two terminals together, that's the positive and the negative terminals, you can have an electrical energy. Is that okay? So a cell actually converts the chemical energy to electrical energy. You know, if you want to produce electricity from your simple battery, just connect the positive terminal to the negative terminal, then connect a bulb, right? Connect a bulb to the setup and then close the switch or close the circuit. You see that the bulb will light up, right? So that is just the chemical energy that is stored in the battery is what you are converting to electrical energy. And you know, for a primary cell, with time, as the chemical energy is working and giving you light, the chemical in the battery cell is being used up, and before you know, the light that is producing will start to dim. Okay, so we have two types of cell actually. So we have the primary cell, and then we also have the secondary cell. So the primary cell produces current as a result of non-reversible chemical changes taking place between the various components of the cell. That is exactly what I've just said, that in a primary cell, as the chemicals in the chemical components of the cell, they are giving you electrical energy. Gradually they are used up, and as they are being used up, that process is not reversible in a primary cell. All right, so we have two examples of the primary cell that are basically um, that you need to basically know, and that is the Leclanché cell and the Daniell cell. So these are examples of simple cells that we have: the Leclanché cell and the Daniell cell. These are the simple examples of the primary cell. So as I've said before, these cells cannot be restored after they have been used up. Right? That is, the chemical component of these cells cannot be restored after they have been used up. So what that means is that these cells cannot be recharged. You know, like in Nigeria here, we have some very simple cells, like we have all those small batteries that we use. Once you have used them up, you cannot recharge them. Okay, so those type of cells, they are known as primary cell. That is the battery that you use for your torchlight. You know, that battery, the one you use for your wall clock, the one you use for your remote control, and all that, they are examples of simple cells. And once they are being used up, you cannot recharge them. Okay, I hope that one is clear. So a Daniell cell consists of this component: one, a copper vessel filled with copper sulfate solution. It also consists of a porous pot containing dilute tetrasulfuric acid. This is the electrolyte. Okay, the H2SO4, this is dilute tetrasulfuric acid, is electrolyte, right? Dilute H2SO4. This is the electrolyte for the Daniell cell. Then we have amalgamated zinc rod immersed in the acid. Then the zinc rod acts as a negative terminal, while the copper acts as the positive terminal. So there are two terminals. We know that there are two terminals in every battery. So you have the positive and the negative terminal. For the Daniell cell, the zinc rod is the negative terminal, while the copper is the positive terminal. Then there is also what is called a depolarizer. The depolarizer is the copper sulfate solution. Okay, so these are the components of the Daniell cell. So how does it work? Okay, so this is just a drawing of the Daniell cell that we just described. Alright, so this is the zinc rod, the zinc electrode, which is the negative terminal, and then this is the copper electrode, which is the positive terminal, right? So the negative terminal is the anode, and then the positive terminal is the cathode. All right, so this is just the setup that we have. Okay, so when the zinc is joined to the copper by wire, just like the way it is in this setup, the zinc will begin to dissolve and bubbles of hydrogen are formed on the copper plates. Okay, so as zinc dissolves, here bubbles of hydrogen are formed on this copper plate, and as this process is going on, electric current is flowing, right? Electric current is flowing from the positive electrode to the negative electrode, while electrons are being attracted to the positive electrode. and as this process is going on, current is flowing, and as current is flowing, a bulb that is connected in this setup will light up. The lighting up of the bulb indicates that current is flowing through the setup. So the chemical components, as this process is going on, the chemical components of this setup, they are used up, and then the cell produces current. As I've said before, this cell cannot be recharged. It cannot be restored or recharged. The chemical components of this system or of these setups, they are used up as they are producing current. The chemical components are used up. Okay, so this is how the Daniell cell works. This is how it works. So we'll also look at the Leclanché cell, how it works too. We'll look at that one too. So this is also an example of a primary cell. As I've said before, the Leclanché cell is an example of a primary cell. And what does it consist of? One, it consists of a carbon rod. Okay, so if you look at it, you see the carbon rod that is immersed in a pot containing a mixture of magnesium dioxide and powdered carbon. Okay, so this is your carbon rod, and what is inside here is a mixture of magnesium dioxide and powder of carbon. This carbon rod is the positive terminal, and then you have a glass jar that is filled with ammonium chloride. Okay, so this glass jar, this is the glass jar. It is filled with, what is here is ammonium chloride. Okay, what is here is ammonium chloride. Then you have the zinc rod that is immersed on the ammonium chloride. So the zinc rod, which is the negative terminal, is immersed on the ammonium chloride, while the carbon rod, which is the positive terminal, is immersed in what? Manganese dioxide, a mixture of manganese dioxide and powdered carbon. Okay, the zinc rod is the negative terminal, then the copper rod is the positive terminal. The ammonium chloride is the electrolyte, while the manganese dioxide is the depolarizer. Okay, so the depolarizer has its own function. So the depolarizer is a chemical that is added to the electrolyte to remove hydrogen bubbles that is collected at the electrode. And we have the phenomena that is called polarization. Polarization simply is just the formation of bubbles of hydrogen in the positive plate of a cell. So, because as I said before, once you settle the process and there is electricity generated, hydrogen bubbles will begin to form on the positive terminal. Now, as the hydrogen bubbles have been formed, you need a chemical component to remove the bubbles. So the formation of those hydrogen bubbles is what is called polarization, and then the chemical that removes the hydrogen bubble is what is called a depolarizer. So please just take note of that. Depolarizer is added to the electrolyte to remove hydrogen bubbles collected at the electrode, while depolarization is the formation of hydrogen bubbles in the positive plate of the cell. Okay, so I hope that is clear, and you can always remember these simple definitions and explanation. Alright, so that is the Leclanché cell, and we have other discussion on this Leclanché cell. So the Leclanché cell actually has a wet type, and that is the one we just discussed now. This is the dry type of it. Okay, this is the dry type. The dry type consists of ammonium chloride in the form of a paste mixed with starch. Now this dry Leclanché cell actually is the type of battery we use at home. So the battery you use at home for your torchlight, for your remote control and all that, there is an example of a dry type Leclanché cell. So you know that in that your battery, the top is your, or you have the top of it, which is that has a carbon rod. So you have the positive part of it. Then the negative terminal is the zinc container. The manganese dioxide is the depolarizer for this particular cell. So we should take note that this cell has the dry type and then the wet type of the cell. Okay, the function, they are just the same thing, so there's no difference, just that in this particular cell the electrolyte is a paste that is mixed with starch. It's not liquid, it's not solution, it is a paste that is mixed with starch. All right, so I need you to take note of that. Now, as I said before, we have two types of cell. So we've discussed the primary cells, and we said that the example of the primary cell is the Daniell cell and the Leclanché cell, and we have seen the different constituents of the two type of cells, right? Then I said the second type of cell is the secondary cell, which is an example of a lead acid accumulator. And this type of cells, they are cells that are rechargeable. Okay, so which means that once the chemical components are used up, they can be recharged. So this cell consists of a positive rod of lead peroxide, a negative pool of lead plate, and an electrolyte of dilute H2SO4. So that battery that you use in your car is an example of a secondary cell, and it is also an example of a lead acid accumulator. As I've said before, the chemical reaction here is reversible, and if you want to reverse it, or if you want to charge this battery, you connect the current in the opposite direction. So this type of batteries, example of them is you have the lead acid accumulator I've said, you have your alkaline batteries. These are the ones that we use in some cameras. We use the alkaline batteries in some cameras and in some other electronic devices. One key thing about these batteries is that they have low resistance to current and they produce large current. They have low resistance and they supply large amount of current. That is one good thing about this secondary cell or lead acid accumulator. Okay, so this is just what we need to know is the component or the constituent of this type of cell. The electrolyte is H2SO4, dilute H2SO4. Then you have the positive plate of lead peroxide and the negative plate of lead plate. Okay, so this is all about lead acid accumulator. And before we leave this topic, I decided to put a summary of some information that you need to know about production of continuous charges. Okay, so this is a summary information that you need to know, and this information summarizes all that I've discussed so far. All right, so examples of simple cell, as I've said before, we have the Daniell cell, the Voltaic cell, and then the Leclanché cell. Right? Polarization, as said before, is formation of hydrogen bubbles on the copper electrode. Alright, so the copper electrode is the positive plate of the cell. Then polarization can be eliminated by one, addition of a depolarizer, and that is the copper 2 sulfate solution for the Daniell cell. Okay, and you can also remove it by adding iron chloride. These are what you can use to remove polarization, formation of hydrogen bubbles on the positive plate. Then there's what is called local action. Local action is formation of hydrogen bubbles between the zinc and its impurities. That's the formation of hydrogen bubbles between the impurities of the negative plate, which is the zinc. Okay, so that is what is called local action, and it can be eliminated by dipping the zinc in mercury, and that process is called amalgamation. Okay, by dipping the zinc in the mercury to form zinc amalgam, that process is called amalgamation of the zinc. All right, so please take note of this information, because these are questions that you can be asked in objective. It can be even in theory question, you can be asked to define local action and how can local action be removed from a cell. So you can remove local action by amalgamation. All right, or the process by which local action is removed from a cell is called what? Is amalgamation. All right, so these are typical JAMB questions that you can come across, and you can also be asked what is used to remove polarization, or what is a depolarizer. So these are questions, and that is why I decided to bring them up as a summary. As I've said before, primary cells cannot be recharged, so please take note of this. Once they are used up, they cannot be recharged. Secondary cells can be recharged when used up. They last for a longer time without polarization. Right, and these are the type of batteries or cells that are used in motor vehicles. And these cells can also be called storage cells. Right, example are lead acid accumulator and nickel cadmium or nickel or alkaline cells. These are all examples of secondary cells. Now, there are these secondary cells, they still have their small disadvantages. One of them is that they are heavy. You know that battery, if you carry a car battery, they always have weight, so they are heavy to carry. They can easily be damaged. If they fall from your hand, they can easily be damaged. The plates are attacked by acid if left unused for a long time, and that is true. So if you leave these batteries for a long time and you see that, then you see some coating forming on the plates. Then for alkaline cell, they can also be recharged. They have a longer lifespan than the lead acid accumulator, and the electrolyte requires no attention. So these are just some of the advantage of the alkaline cell and some of their properties. So please, you need to take note of this information that I hear. This is a summary of all that we have discussed on this production of continuous charges. All right, so I hope this lecture is clear and it's direct to the point, and I hope you have benefited a lot. Okay, so this is where we are stopping on this particular class, and then please do a revision from your own textbooks, and then you can have this. You can have this as your summary notes or your lecture notes as you prepare for your examinations. All right, so thanks so much for your time. Before I leave, please, if you have not subscribed to the channel, please subscribe to the channel. Click on the notification bell so that when we upload a new video, YouTube will notify you. This is No Man's Science Tutors Online. I remain Otobo Michael, your online tutor, and you can reach me through the WhatsApp number that is showing on your screen. We are here to make sure that physics is as simple to you as much as possible. So wish you the best as you prepare for your coming examinations. Please continue to be serious with your studies. If you want to come out with good grades, right, review all the videos that were uploaded. As I said, we have uploaded from SS1, we are SS2, and we are going to SS3 gradually. So we are almost completing the course on physics. So just shortly you will see that we'll upload all the videos that are required for you to complete your course in physics. Then we'll do some revision videos in some past questions. All right, so guys, have a nice day, and we hope to see you in our next class. Please invite your friends, give us a thumbs up, give us a like to encourage us as we do our best to make physics as simple as possible to you. So thanks, and have a nice day.